No, I'm just kidding. So basically, we have the front end we have a lot of the car off right now. And one of the things that we're working on is going through all the suspension options and some of the suspension tuning options. So one of the processes for that is the front suspension is off because it got basically crack checked using MagnaFlux. And it's the neon green stuff that you see like normally in crack checking procedures, and now gives us a really nice opportunity to go in and kind of see generally what's underneath all the suspension in this car. And you can see that there's, in total, side to side, there's 6 of these stainless tubes that go to cooling different parts. We can change them where we want, but right now we have on the driver's side, we have one going towards your face, one going towards your feet, and another one going towards the header. And then on this side, we still have it going one towards the passenger, one at the passenger's feet, and one at the headers. But we can change them out. And on this side, if we're racing, we don't need them to go towards the passenger. We need them to go towards probably cooling the engine more. So that's a really neat thing. And you can see one of our swirl pots right here. It's got these gamma connectors on here. Kind of a fun fact is those are the same connectors that are in like an F16 fuel line. They're really easy. All you do is I'm not going to do it because there's water in the system, but you just basically pull this apart and then twist it, and it comes completely apart, and it's super, super easy. It's super handy. So this is one of those gamma connectors that I was talking about. It has a Wiggins style weld-on bung that goes on it. And basically all you do is you pull it apart. It's a little bit easier when it's actually on the car and weld it in. And you just twist it apart. And then there you go. There's the 2 pieces. And it's super, super easy and super quick. So they'll just go together like that. And they'll, listen to this. They snap together. So we've had these sitting in a drawer for 20 years. And we decided hey, we might as well use these on the car. If you're wondering where you find these, you don't. All right, so one of the things that that Barris Engineering wanted us to improve, I'm going to scoot forwards. Basically, one of the things that they want us to improve when they first came and scanned the car was we have the panel out right now, but this is all, the entire inner fender is paneled in. And then this was actually just a continuation right here of the fender. But they were like, we probably want a smoother transition, so we put this waterfall panel in. And now any air that gets trapped in here is just going to flow out. So it's just a way smoother transition and all of that. So it's just kind of a neat thing. And it's fully functional. And then if you're looking on the outside, you'll kind of notice that the fender doesn't kind of stop midway up here. It keeps going. Up in this area up here, basically any air that gets trapped underneath the hood can exit on the secondary upper portion of this fender. So that's kind of a neat thing. Yeah. So if we come over here, you can kind of look inside. You can kind of look inside there. You can swap with me. So you can see that this is obviously where the waterfall panel section is, and up here is where basically the air from the underneath the hood can exit and prevent any lift, because you're fighting for all the downforce in the world that you can get. Last thing you want to do is create lift. So yeah. So this is one of the underfloor panels. So if you saw our last video, you can see that we went underneath with the air jacks and we were showing some of that stuff. But it was kind of hard since it was dark. You couldn't see what the underfloor looked like. So this is obviously the section that you'd look at if you're underneath the car. And there's still some stuff we need to do. We need to edge fill this, and we have some final hardware insertion we need to do. But this is generally it. And so it's from Composite Visions. You can buy these sheets straight from them. How big are the sheets, Dad?
You can get them any size you want, but we got 8 foot by 4 foot.
So you can get them any size you want. We get them 8 foot by 4 foot, and This is it's Xylon and carbon fiber, so it's got some anti-intrusion properties. And like this car is like 2 inches of ground, and your like butt's like 5 inches. So like anything underneath, you don't want to get like speared. So this is also from Composite Envisions. It's just straight up carbon fiber, and you can buy it in any size sheet. We just opted for 4x8, and this is what you see on the other side. So if you're like working underneath, or you pull the hood off and you look down, this is what you're seeing at the very bottom. So yeah, it's just a sweet kind of nifty panel. This is the one that goes in between the front wheels, and then there's a front splitter section one. And yeah, it's pretty sweet, pretty fun. So, wait, should we do the transition? Should we go do the transition? Now that we're done talking about the front end of the car, let's go to the back end of the car. Now that we're in the back of the car, there's a lot more cool stuff going on. So one of the things, our wiring guy, now that we've run the car and kind of proven some stuff, he's finally gone around and kind of glued some of the boots onto some of these. I'm not going to mess with that. It's drying. So he's finally glued some of the boots onto the wiring harness. And there's a few things. So now we've taken the suspension off. Since it was getting crack checked and everything, and we're going through our tuning options. And now you have a kind of an easier view of the turbos that we went over a little bit in the last episode. And you can see that we converted the car from a normal sequential shifter that you just manually operate to a sequential one since we have paddles. So there's a bracket that I designed and that Veris Engineering machined up for us. And then it mounts to a Motec pneumatic actuator. So that's why there's an air compressor tank and an air compressor in the trunk. It's to operate that. And it just really quickly just pneumatically shifts. And when we were first like trying it out, it almost sounded like it was going to like break the transmission. So then my dad was like, hey, we should probably try turning down the pressure. And we tried turning down the pressure, and it didn't shift right? Yeah, it just didn't work right. So we turned the pressure back up, and we're probably going to turn it up a little bit more. And it's pretty sweet. It's like normally on this transmission, you wouldn't think it would be like that easy to switch it over, but it was pretty easy to switch it over for this system. So you're probably wondering what these are doing in the car and why there's a little bit of a groove. Why there's a little bit of a groove in this spot. And that's because when we're at the track and we want to set the camber, or we want to deal with the cambers and the toes and just generally set up with the car, we're going to weld on a tab. I think it's going to live probably on this side. We're going to weld these basically a tab, so these can basically bolt in. And once that's in, these will be set length, and then you just run like a string all the way down, or all the way to the front of the car, and then you can do all your measurements based off that. So it's a way, like once the car is set up on a setup pad, you don't want to really change too much. So then when you're at the track, you can actually make these real adjustments. So it's kind of a sweet thing. Yeah.
All right. I want to take a couple minutes and show you what we have for steering options for Hammerhead. So we can address a couple of issues. One of them is just how fast the steering is. And we can do that two ways. We can do it with a steering rack. We have in the car a 10-tooth rack, which is our fastest rack. And then we have a 7-tooth rack that slows it down a little bit. And then like if we were in a track that had a really tight hairpin, we'd want the 10-tooth rack in there, because it literally is about, to go through a hairpin, it's about a half or 3/4 of a turn of the wheel to make a really sharp turn. The problem with that is it takes a lot of effort. So we've got different ways to address effort, but each one of them also either increases or diminishes our wheel angle, our tire angle. So we've got our shortest steering arm that we have in low Ackerman is a 135 millimeter. And then we have a 150 millimeter. And then we have a 170 millimeter. So we have 3 different lengths that we can play with to slow the wheel down and make more or less steering effort. And then on top of that, we can play with 2 different lengths high Ackerman steering. So that's the difference in a high Ackerman is where this location is compared to where the upper wishbone attaches.
Explain Ackerman.
It's the difference in how much, when you turn the wheel in the car, if it was a low Ackerman, they would have a very similar amount of angle right and left. And then if you have a high Ackerman, you end up with a situation where you have the ability for the the inside tire of the turn to turn even a little more than the outside tire, just to help you through the corner. It's about tire scrub, and it's an engineering philosophy that I probably don't know enough about. But
well, I mean, I can kind of butt in real quick and explain that.
Yeah,
I'm gonna
do it
forward. But basically, I want to go over here. But basically, like the whole idea of this Ackerman, like if you have really even one, you probably have a really fast, straight course, I imagine, right?
Yeah, it could be. I mean, it's all about how tight the corners are.
Yeah, because like if you have a really, really tight corner, if that inner wheel is turning more,
yeah,
when you're going around a radius and you have, like, let's say you have two circles, one's going to have a shorter radius and one's going to have a larger radius, and they each have different trajectories almost, right?
Yep.
So then if you have the inner wheel turning more than the outer one, it's going to be able to make that corner better. It's going to be able to use it, right?
Yep. No, there's no doubt about it. You know, it'd be interesting to show you too just how these steering arms fasten to an upright. You see this one's in place on an upright that we have built up, and you've got 3 fasteners holding it down. So you've got serrated edge on the bottom of the steering arm here, and you got a serrated edge in the top of the steel upright. This upright doesn't have studs in it yet. We're about ready to send this out, have it crack checked, and then we're going to build these uprights. But it basically sits on those studs. You line up the serrated edge where it can't turn, and then you just clamp it down with the nuts on these studs, and that's really all that holds it in place. And the nice thing, to change cambers, all you do is you just walk it in or walk it out on that serrated edge and tighten it back down. Each one of these serrated edges is supposed to be around 1/4 degree of camber. Very easy to use. You can change a camber in one of these things in, I mean, you take the wheel off, change the camber setting, put the wheel back on, and it might take you 30 seconds.
Okay.
Yeah, I mean, it's really fast.
Versus like like if you had a more conventional setup in a normal car, you'd have to get out there and literally, you have to wind out the
rod ends and all kinds of stuff, take the bolts out, wind out rod ends and do all kinds of things. This is very efficient. On the rear of the car, we have what's called a shim system. And you just loosen up these 2, basically 3/8 bolts, and you just slide in or take out a shim depending on which way you want to go with the camber. And here's the other thing we can do is if we want to, we can raise or lower this point on the upright. That's just a roll center change. Anytime you raise or lower these points, you're changing the roll center of the car. So it's another way, another tuning options that we might get into at a later time, but we have that available to us as well. That pretty much covers the steering options.
Yeah, that's just steering.
Yeah, it's just steering. I'll show you some other ones in just a second.
Yeah. So.
Anyway, there's a lot that we'd have to dissect here. I think it would take a lot I'd have to refresh my memory on a lot of this stuff. Different roll centers, like if you're around a road track, those are the rear suspension settings. And I can show you those. Those are what we're talking about here. When we talk about some of these mounts.
Oh, those are really neat.
These are all titanium. So I've got enough for both gearboxes. They're all different ones to be able to go all different heights. But I've got enough for both gearboxes to do the locations that we might need to do if we're changing roll centers. This one's the most. Look how high that one is coming.
Oh yeah, it brought it way up.
Yeah.
This is like those videos where you see the guy, he's like, go band for band. Go band for band. And then...
Yeah, so that's kind of what these are all about, is you're just trying to figure out from the lowest to the highest. And then on the gearbox, under the drive flange. This one only has the 4 stud locations, but this one has 6 locations. So you can take this whole thing and go up a whole row of
on top
holes.
of the adjustment that you already have. Yeah.
Yeah.
Wow.
We got enough to get really lost.
Yeah. go way the wrong direction.
Now, that's why you have to start off with known geometries, and you have to kind of understand what each one does to the geometry, like, what roll center and then anti-squat or anti-dive. So I want to go through a couple of options we have for our front roll bars. So we have a blade that goes through here and it rolls on these roller bearings, and we can adjust it in the cockpit from full stiff to full soft. And that blade helps us determine sort of a direction on whether we need to go stiffer or softer. It gives us some adjustability during a race to make it stiffer or softer, depending on how your tires are wearing or what the handling's doing. But anyway, we have 4 different sizes for the front. We have a 22, a 19, 16 that's on the car, and a 13 millimeter. And on the rear, same situation. We have a blade in here, and it can be adjusted in the cockpit. But we have this massive 27 millimeter bar, and then we have a 20 and an 18. And then I think this one's maybe a 13. I think it's a 13 millimeter. And then lastly, this is a titanium bar that obviously is in a blade form, so it gives you some ability for some twisting, and it has a very good memory. So these work really well on street courses where you may not even want to run a bar all the time. So that's about it. And then we've got some rocker options next.
We got these new mics, and they're super loud, like super, super loud.